Hi guys, so this is a supplemental video that I'm making attaching to the 19.6 because quite a few of you guys told me that you are having problems solving, specifically solving for x values or angles that are not special right triangles. And when you are using your calculator, some of you guys are having problem understanding why my solution comes out slightly different than yours. So I'm doing this supplemental video to kind of address those confusions that some of you guys have talked to me about. So let's start with the question. So we have a question where it says sine of x equals to negative 0.15. So the direction of these questions will probably say something like find all solutions where sine of x equals to negative 0.15. So first of all, the context of the question you're in is you're talking about a function of sine of x, which means x can be any real numbers you need because the domain for y equals to sine x is all real numbers. In order to solve for x, and again, negative 0.15 is not a trig ratio that we know that comes from special right triangles. So we're going to have to use a calculator for this. Make sure, again, you're in radian mode when you're using a calculator. Okay, so we're going to put in arcsine of negative 0.15 is equal to x. And when I put that in, my calculator gives me a radian measure. I'm going to type this in right here. That x is approximately negative 0.151. So we're going to take a minute and actually really think about what that means. So we know x is the ratio, negative 0.15 is the trig ratio. X is the angle, okay? X is the angle in radian measurement that when I take the sine of the x value of negative 0.151, I will get a trig ratio of negative 0.15. Now, so in standard position, where is this angle located? Because it's actually very important for us to address what that is because it tells us a lot of different things when it comes to solving. So negative 0.151 being a negative radian angle. And again, negative 0.155, if you think about it, it is definitely closer to 0 than negative pi over 2. So it's doing a quadrant that has negative pi over 2 to 0, which we know as the fourth quadrant. And think back to what we learned about unit circle. Sine is actually negative in both the third and the fourth quadrant. Now, so negative 0.151 is located in the fourth quadrant, which also corresponds to what we learned about the range of y equals to arcsine of x. If you guys remember when we did the inverse trig functions, the range for y equals to arcsine of x is between negative pi over 2 to pi over 2, which if you think about that in the unit circle perspective, that is from the fourth to the first quadrant. So we know negative 0.151 is an angle, if I were to draw it, that will be in the fourth quadrant. So this is my terminal side where this is my initial side. And if I were to input the actual angle, which I'm about to do right now, if it will let me. Let's see. Okay, there you go. So there is my angle. This is a rotation of clockwise because it's a negative angle. And the angle here, if I were to insert it, the reference angle, okay, again, the reference angle, let's see where I can put that in. The reference angle, okay, of this particular part here, do a text box, simple text box, okay, take it right here, make it really small. The reference angle here is 0.151. That's in radian, okay? So essentially what we're saying, I'm gonna make this is I'm saying this angle right here is negative 0.151 and it's in the fourth quadrant with a reference angle of 0.151. So in what we know about the period for sine, in order for me to go to the other, so if I rotate one more time, counterclockwise, I will be subtracting negative 2 pi, or if I rotate one time clockwise, I will be adding 2 pi. It will give me my coterminal angles. So if I add 2n pi to that answer where n is an element of integers, this will give me all the coterminant angle to this particular angle, no matter how many times I'm rotating and whether I'm rotating clockwise or counterclockwise. But keep in mind, that only gives me one negative angle within the period of sine, which has a period of 2 pi. And sine, like we said earlier, it's both negative in the fourth and the third quadrant. So what does that mean? It means that in the third quadrant, I also have an angle, and it kind of looks like this. Because remember, in order for two angles to share the same trig ratio, they have to have the same reference angle. What that means is that in the third quadrant, I have another angle, okay? In the third quadrant, I have another angle, okay? And this angle has a reference angle of 0.151. So this angle right here measures 0.151. But how do I find the actual radian measure that goes from my initial side all the way to my terminal side? Because this is my terminal side. Well, this is 0.151 radian more than pi. So one option I have is to take a positive angle of pi, add 0.151, and it will give me the radian measure for an angle that ends on this terminal side. And when I do that, I get a second solution. Okay. And this solution is going to be, it's not negative anymore, it's actually positive, because now for this case we're actually rotating counterclockwise. It's positive 3.292 plus 2n pi, and n being an element of integers. So I'm going to insert the actual angle so you guys can see clearly what angle I'm talking to when I say 3.292. And the angle measure, the actual angle we're looking at, oops, that's the wrong one. Okay. Let me see, well, let me pull up that special one. Here we go. Okay. Let's see if it will let me do it. Okay. I know this looks really big. This is looking a little silly, but you guys are going to get the picture here. So the angle I'm talking about, okay, that also has a trig ratio of negative 0.15 is in the third quadrant. And to get that actual angle, we know these two angles both share the same reference angle, which is 0.151. But to find the actual angle, I have to take this into consideration, which is pi. So this actually becomes 0.151 plus pi, and that will give me the radian measure for the second angle right here. And that's how I'm going to find the second angle. Now, how do I know there's no more than 2? Because within one trig ratio, within one unit circle of sine, if you really think about it, you can even think about the graph of y equals to sine x. If I graph y equals to sine x and I graph the horizontal line of negative 0.15, within one period, how many times will my graph intersect that y equals to negative 0.15? And the answer is it's only going to intersect once. Okay, so that's how you would do something like sine. Now, how would you do something like cosine? So let's take a look here. I'm going to have to come So in this case, I decided to propose a question. What happens if I say cosine of x equals to 0.73? So it's the same idea. I'm going to have to do inverse cosine of 0.73 equals to x. Again, please make sure you're in radian mode, not degree mode. Okay. So if I put that into my calculator, x is going to be roughly, and again, make sure you're in radian, not degree mode. So arc cosine of 0.73 is going to give me 0.752. Now, thinking about that in terms of unit circle, okay, 0.752 is definitely less than pi over 2, but is greater than 0. That means my angle that has a radian measurement of 0.752 is located within the first quadrant. And that makes sense because if we talk about the range of arc cosine, okay, again, the range of arc cosine, if you guys remember, it's from 0 to pi, which means it is in the first and second quadrant. And we know cosine is positive in the first quadrant. So 0.752, it's probably halfway between if you think about it, because pi over 2 is about 1.57, so 0.75 is about halfway through. So what I'm saying then is this is the measurement of my angle in center position, and this particular angle, this one right here, okay, has a value of 0.752. Now thinking back again, the next angle that will be coterminal, because all coterminal angles share the same trig ratio. So the next one that's going to be coterminal to this will be if you add or subtract 2 pi, because again, the period of cosine is also 2 pi. So to get to all the solutions, I have to put 2n pi. Okay. Where n is a element of integers. Yes, but here's the thing, that's only one solution. Within one period of cosine, which is 2 pi, there should be 2 incidences where cosine is actually equal to a positive value like 0.73. So if we think back to unit circle, we know cosine is positive again in the fourth quadrant. Okay, so cosine is positive in the first and the fourth quadrant, which means I'm looking for an angle, okay, and it's going to be in the fourth quadrant. Now, the interesting thing is, because again, the reference angle has to be the same. That means if this was a positive 0.752, this angle right here, which also has to have a reference angle 0.752, I'm rotating clockwise, which means this angle has a measurement of negative 0.752. Okay, so that means all I have to do to get my second solution is I just have to basically make this negative. And then in that case, it will actually show me the second angle, which is in the fourth quadrant and has a reference angle 0.752. So there it is. This is the second one I'm looking for. So, and again, if you think about the actual graph of cosine, what it looks like from 0 to 2 pi, if I were to graph y equals to cosine x and I graph y equals to 0.73, how many times will my graph cross that horizontal line? And the answer is twice. And again, guys, you can always verify these answers using graph, but we can clearly tell these two are not coterminal angles and they're not the same angle. That's the reason why you have to write them twice. You cannot put them together into one solution. Same thing like what we did for sine. Okay, so I hope this addressed your guys' confusion regarding how to find a second solution within one period of sine or cosine when you don't have something that's a special right triangle. If you have questions, make sure you contact me on Remind and you ask your questions. Okay? All right, thank you for watching. Bye.